In the vast universe that surrounds us, we're often enchanted by the grandeur of galaxies. Yet, there is a universe right here on Earth. A universe so minuscule that it's invisible to the naked eye, yet it holds the potential to revolutionize every aspect of our lives. Welcome to the Nanoverse, the home of nanotechnology. This word originates from the Greek word nanos, meaning dwarf, and it's the science of engineering and application of materials that are approximately between 1 and 100 nanometers in size. To grasp the scale of this, consider a sheet of paper, which is about 100,000 nanometers thick. It's at this minuscule scale that nanotechnology operates, allowing scientists and engineers to build materials and devices atom by atom. From its inception, nanotechnology has been a captivating field. The term was first coined by the Japanese scientist Morihiro Taniguchi in 1974. However, it was the seminal talk by physicist Richard Feynman in 1959 called "There's Plenty of Room at the Bottom" that truly ignited the scientific community's interest in this sphere. Feynman envisioned a world where we could manipulate and control things right down to the atomic level. Nanotechnology has evolved tremendously since then. Today, we use advanced techniques like atomic force and scanning tunneling microscopes, which enable us to not just see individual atoms, but to manipulate them as well. Nanoscale transistors, the building blocks of all electronic devices, have already become a reality, powering the technology you use daily. IBM, in its quest to go beyond silicon, has recently created a 2-nanometer chip, offering 45% higher performance than today's most advanced chips that are nearly 3 times the size. The most groundbreaking application is its role in medicine, particularly in targeted drug delivery. Traditional drug delivery methods, while effective, often disperse medication throughout the body, not just the intended target area. This broad-spectrum approach can lead to side effects, as healthy cells are exposed to the drug just as the diseased cells are. But what if we could pinpoint only the diseased cells, leaving the healthy ones untouched? Nanomedicine proposes a way to achieve targeted drug delivery. Researchers are developing nanoscale particles or devices that can be loaded with drugs and then injected into the body. These nanobots are so tiny they can move freely in our bloodstream and can be programmed to attach themselves to specific cells, like cancer. For instance, a study by researchers at Arizona State University demonstrated the effectiveness of these nanobots in mammals. In their study, they were designed to carry a payload of a blood-clotting enzyme. When these nanobots came into contact with a tumor, they delivered their payload directly into the cancer cells, causing them to clot and effectively starving them to death. The study showed that the nanobots had no effect on healthy cells, thus reducing the side effects typically associated with cancer treatments. Nanotechnology's possibilities in the field of medicine are awe-inspiring. However, its reach extends far beyond just health and wellness. It is also revolutionizing the world of manufacturing. Let's consider the wonder material, a material made of single-layer carbon atoms arranged in a 2-dimensional honeycomb lattice. Graphene is the first known 2D crystal. It's over 200 times stronger than steel, yet incredibly lightweight and flexible. But where does nanotechnology come into play? Well, its incredible properties are a direct result of its nanoscale structure. According to a report by the University of Manchester, where it was first isolated, this material could be used to create lighter, more energy-efficient and stronger airplanes. They estimated that this change could reduce the weight of an aircraft by 4,500 pounds, leading to fuel savings of up to 0.55 million liters and a reduction in carbon dioxide emissions by 4,472 tons per year. Moving from skies to screens, nanotechnology also holds promise in revolutionizing our digital devices. Nanocrystals, or quantum dots, emit light when stimulated, which are used to enhance color and energy efficiency in televisions. Companies like Samsung and LG have already incorporated quantum dot technology in their QLED TVs, offering unprecedented color ranges and contrasts. Researchers at Stanford University have also developed a type of solar cell that is roughly 100 times thinner than a human hair. These cells are not just incredibly thin, but also more efficient than traditional solar cells, with efficiencies reaching up to 24%. Imagine the impact of wide-scale implementation of such nanotech-driven innovations. We could see a significant shift in our approach to energy and sustainability. The world of nanotechnology is an exciting, fast-paced field, and we are only scratching the surface of its potential. So, with that, remember to stay curious, keep exploring, and let's dive into the mysteries of our universe together.